It's your friendly math tutor, Miss C here, and today we are talking all about functions, including composite functions. So we're going to just start with basic function notation and what that means, and then we'll jump into a series of composite functions. So I'm reading the first part of this problem, and it gives me a couple statements. It says, let f of x equal x minus 4, g of x equals 2x squared plus 5, and h of x equals the square root of 7x minus 6. So we've got three different functions. How we know what function we're talking about is by the first letter of each function. So just as a quick reminder, hopefully you know from your math class that this is not f times x. We read this f of x, and what that means is wherever I see function f, I substitute in whatever x value there is. So let's jump into this. We are starting with h of 3, and we are to find that. So I need to find function h, that's this one right here, and you can see that the x has been replaced with the number 3. So h of 3, everywhere I see x, I'm replacing with the number 3. So you can see that I replaced x with 3 in those two spots, and then all I'm going to do is simplify like this. And h of 3 equals the square root of 15. I think that's a fine answer. You could always put that in and get a decimal if you want, but root 15 is going to be a very long decimal. So one of the reasons we like this notation in math is it tells me that when I looked at function h and I plugged in the value of 3 for x, I got out root 15. So you end up with your coordinates. All right, let's do another one. I am looking for g of negative 4. So I need to look at function g, that's this one here, and everywhere I see x, I'm going to be plugging in negative 4. Okay, trick on this one, you're plugging in a negative 4 into a value that's squared, so it's x squared. So that negative 4 has to go in parentheses. Okay. All right, negative 4 times negative 4, or negative 4 squared is 16, plus 5. When I do that, I end up with 32 plus 5, which is 37. All right, once again, we know that because we used function g, when we plugged in negative 4 into that function, we got out 37. And our last one is f of negative 1. So I'm looking at this function here, and everywhere I see x, I'm plugging in negative 1. So once again, you can see that I replaced all the x's with negative 1. When I do that in this linear function, I know that when I plug negative 1 in for x, I get negative 5 out. All right, so that is the basics of function notation, but sometimes we have composite functions. So that would be this down here. So composite functions, and I've got the functions down here. Composite functions are more than one function put together. And when we're dealing with composite functions, we deal with the inside first, and then we deal with the outside. So for example, we would read this as g of h of x. So what we're going to do is we are going to deal with h of x first. And what we can tell is h of x is what I have right here. So all I'm going to do is replace h of x with what h of x equals, which is the root of 7x minus 6. Now we have g of the square root of 7x minus 6. So now we look at function g, and everywhere we see x, I'm going to grab a different color, we replace with the square root of 7x minus 6. So I'm going to go ahead and do that. So I have 2 times, I'm going to put this in parentheses because it's squared, 7x minus 6. This whole thing is squared plus 5. Okay. All right. And now I'm just going to simplify this. And I'm just for our highlighting, you can see what I substituted here, this whole thing. Okay, I'm going to go ahead and simplify. And I get 2 times The square root of 7x minus 6 squared gives me 7x minus 6 plus 5, which gives me 14x minus 12 plus 5, which gives me 14x minus 7. Okay, but here's the catch. This is g of h of x, so my final answer should show that the composite of those two functions equals 14x minus 7. All right, so the reason I still have a variable here, so you're going to see this variable, is because I have a variable here. All right, so this equation, g of f of x, this one that we're working on right now, is we're going to handle it the same way, except what we're doing is we're looking at f of x first. So everywhere I see f of x, I'm going to be plugging it in here. So I'm going to say that I'm going to start by saying I have g of, and here's my f of x, x minus 4. So I'm just doing a straight out substitution. Okay, and you can see that I replaced f of x with x minus 4 in both of these. Okay, all right, so my next step then is to find g of x minus 4. So I'm going to go ahead and pull my g of x minus 4, and everywhere I see x, I'm plugging in, x minus 4. That should have been a 2. All right, and now I am going to, I actually need to FOIL this. So x minus 4 times x minus 4, I'm going to just do this in my head. If not, you could write this out. So I'm just working through the order of operations here to simplify. Okay, so I FOILed this because that's really x minus 4 times x minus 4, which gives us what's in parentheses here. Then I distributed my 2 throughout, and now I'm just going to simplify. Okay, so again, I'm rewriting this as g of f of x because this is what the composite of those two functions looks like. All right, now, sometimes we are going to be asked to find values, and these are more of my favorite because they're a little less work. So let's go ahead and start. Remember, we start with the inside. So we have h of g of negative 3. So we're going to start with g of negative 3. So I'm going to go ahead and do that here. And I'm using my function g. Okay, and everywhere I saw x, I subbed in negative 3, so you can see that. And now I'm just going to simplify this. So g of negative 3 is equal to 2 times 9 plus 5, which is 23. But we're not done because now we need to find h of 23. So you can see that we replaced g of negative 3 right here in this equation. So g of negative 3 is equal to 23. So I'm just substituting. So remember, math is really a series of substitutions. So now I'm going to go ahead and in my h function equation, everywhere I see x, I'm replacing it with 23. Okay, and I'm using this equation in case you're wondering. All right, this is going to challenge my math because so I end up with the square root of 161 minus 6, which is equal to the square root of 155. All right, so I did h of g of negative 3, and you could pop this into your calculator and get a decimal version out. I tend to leave my roots that have a lot of decimals as roots, but you could certainly do that and you would get a number between 12 and 13. All right, so there's that one. Let's do one more. This is a composite of 3 different functions. So we're working from the inside out. So we start with f of 2. So we're going to find out what f of 2 is. So you guys can probably do that in your head. I'm going to write it out for us. So everywhere I saw x, in my f of 2 equation, I put in 2, and that led me to having a value of f of 2 is equal to negative 2. Okay, so then I'm now going to look at the next part. So I'm now looking at this chunk. So g of f of 2. So I'm going to pull my g function, and everywhere I see f of 2, I'm going to put in negative 2. So this becomes g of negative 2. So I'm just doing a series of substitutions over and over and over again. So when I do that, I end up with 2 times negative 2 squared, which is 4. So g of negative 2 is 8 plus 5, which is 13. All right. So now I've peeled back the onion, so to speak, and now I have my very last function. And now that is what h of g of f of 2 equals. So by the way, I should have been a little more accurate about this. This was g of f of 2, right, is equal to 13. Okay, and look what we're replacing. We're replacing g of f of 2. Okay, so now everywhere in my h function, I am replacing with 13. So we have h of 13 equals the square root of 7 times 13 minus 6. Okay, so that is going to equal 91 minus 6. Okay, which is the square root of 85. Okay, but this isn't just h of 13. We started with h of g of f. H of g of f of 2 equals root 85. Again, there's not a great way to simplify root 85. It's going to be another decimal, so I'm going to leave it as root 85. But if you really want to do that, you're going to end up with 9 point something there. All right, so here's the bottom line on composite functions. You work from the inside out, and you're really just doing substitution of substitution of substitution. In problems where you have a number here, you're going to get a number out, just a single number. So in our case, because I had a square root function, I ended up with roots in both of these because h was the first function on both of these problems. Okay. For the problems that don't have values, so things that they just keep the x value in, you're going to end up with an expression. So those are the basics of composed functions. Make sure to like this video if you found it helpful so other people can see it. Subscribe for more math content. And remember, till next time, you've got this.